Hello, everyone, and welcome to the webinar. Today's webinar is a continuation of last week's webinar, part 2 of enhancements in channel synchronization in SolidCAM 2017. It will be given again by Florine Eugene. He will continue with what he left off from last week. And I'd just like to remind everyone that if you do have questions, again, write down your questions in the questions panel at the side of your screen, and at the end of the webinar, we'll try to answer them as best as to our abilities. Okay, Florine, I will make you a presenter, and you can go ahead and start showing your screen and start with the webinar.
Thank you, Sydney. Today, as you already said, we will continue with the second part on Milton webinar. And today topics, let me go back to first slide. Okay. Today topics are axis patterns, axis distribution, and superimposition. And we will find out why we need patterns, how to define distribution of axis, and how to define the superimposition. Now, first I will want to present you the machine. So the machine is a Citizen Swiss type Syncom and L32 M8 type. Let's hide housing and let's see what we have here. We have a turret with linear, it's a linear turret with turning tools from 1 to 5. We have 6, 7, and 8. We have 3 milling live milling tools. And on this device, we have an additional 3 live milling tools. Now, we also have a tool post for the subspindle, which is fixed, not moved by any axis. And on subspindle, we have another 4 tools. How many axes we have here? We have 7. So the turret can move in X, up and down, can move in Y, left and right, and Z axis will bring the stock in and out of guide bushing. And now on subspindle, we have X2 and Z2. Of course, we have the 4th axis C1 and C2 on main spindle and subspindle. So a total of 7 axes, which they can be controlled by both channels. Both channels can take control on this axis. And here comes the definition of axis pattern and axis distribution. When we have a controller with which it can take control on an axis to transfer the control, better say transfer the control of an axis to a different channel, then we need an action. We need to have something in the code to do this. So this transfer of axis from one channel, the control of axis transfer from one channel to another can be done manually or in an automatic mode. As I said, we have a seven axes, which they can be controlled by channel 1 or channel 2. By default, it's always we have a default state when we power on the machine. By default, X, Y, Z, and C1, they are controlled by channel 1. X, Z, and C2, they're controlled by channel 2. Okay, now I talk about the manual mode of transferring axis control and an automatic mode. So the manual mode is using a G-code command G140, and you will assign to X, I will use X1. In Y, I will use Y1. In Z, I will use Z1. And in C, I will use C1. In the same command in the second channel will define the axis. For X, I will use X2. For Z, I will use Z2. And for C, I will use C2. This is the manual mode. We have an automatic mode on machine defined by machine builders. And depend on the machine brand, you will get different G codes, G600, G700, and so on, G800. Each controller with each machine brand with his own patterns. But after many years of studying many machine types, different brands of machines, we see that there are similarities between the controllers, and they all use the same logic. Use macros, use patterns in order to control the axis assignment. So default pattern, default axis assignment in automatic mode is generated here on this machine by G600. Let's open our VMID. Axis patterns in VMID. Here is where we define the patterns. With a right click, add an axis pattern, and you will have a new axis pattern. On each axis pattern, you can define the distribution. What axes are working and where. Okay. We will see why we need so many axis patterns and so different axis distribution. Continue to show you. But here we start with the definition. Now you will see here a lot of numbers. This is a naming format which I choose to use. It's telling me something, telling me what axis, which axes are working and where. Okay, you can rename to any other name, use anything that you think it will be better to understand and to recognize the pattern. Okay, I will explain my logic. I have the 7 axes. First 4 of them, they are assigned to channel 1. The last 3 of them are assigned to channel 2. In the second pattern, I'm not using X and Y, I'm using only Z and C. X2, the first of the last 3, is also assigned to channel 1. That's why I see 0, 0, 1, 1, 1, 0, 0. They are not used. Z2 and C2 is not used here. I'm just looking at the pattern, at this number, and I know which axis is working and where in what channel. This is a way that I found comfortable to me, but again, each one of you with a different logic, you can rename here the pattern however you want. So each pattern have an axis distribution. I already said the first axis, this is the default pattern, the G600. First 4 axes are assigned to channel 1. X, Y, Z, and C, they work in channel 1, and by default, when the machine is power on, they are controlled by this channel. X2, Z2, and C2, yes, they are controlled by channel 2 and by default. Let's go to the second pattern, what I define here. Here I define I will work only with Z1, C1, and X2, meaning if I'm going to machine simulation, Z1 is the material stock in and out from the guide bushing. C1 is the fourth axis on the main spindle, and X2 is the X on the sub spindle. Here I will work milling with one of the 21 to 24 stations on main spindle. Milling on main spindle. This is a combination of axes and tools. One station from 21 to 23, milling tool working on main spindle. I will use X2, Z1, and C1. Another pattern. I have only X2 and Z2 axis in use. X2 and Z2, and let's see the distribution. X2 and Z2 used by channel 2. Here I have a turning combination, turning with tools from 21, 24 on main spindle. So I don't use C axis, I only use X2 and Z2 in order to create a tool pass, turning tool pass on main spindle. Another pattern which you can see already, X1 is used in channel 1, Y1 is used in channel 1, Z1 is used as superimposition. Superimposition meaning this axis will superimpose his position on Z2 axis, on a parallel axis used in the same time. These are all possibilities. This axis can be controlled or not. If not, is forbidden. Can be controlled is normal. Normal and default I will use for if this axis is default on this channel. Superimposition again with combination by default, normal and default. Okay. Now, the machine contains have four defined patterns, but I define additional 2 where I assign all axes in one channel, in channel 1, and all axes in channel 2. This is for MCO actions, MCO cycles that we will define in the post later, and I need all axes in one place. I will show you an example. But patterns defined by in the controller, we have only 4: G610, G600, G610, G620, and G650. Yes, let's go again here and see. So this is the default pattern G600. The next pattern is G610, G610. I will use Z1, C1, and X2 in channel 1. X1 and Y1 is not used. In the channel 2, nothing. Okay, this is the second pattern. The third pattern, G620, I will use only X2 and Z2 turning with the back post tools on the main spindle. All this you found in the programming manual, in machine books, and based on this information, you open the VMID and start definition. Then the next pattern, which is the superimposition patterns, G650, used for pickoff. When you bring the sub spindle, catch the part, use the cutoff, and transfer the part, take the part with the sub spindle. So Z1 here is used as superimposition. he will superimpose his position on Z2. Again, we always have an automatic mode to select only one code in the post-processor G650, or you can use the manual code, which is more complicated. And also the end user, they prefer the automatic mode and not the manual mode. Here, if I define the axis using G140, then I need to use to activate the superimposition G156, Z2, follow Z1, and also G840 synchronize the spinning phase synchronization. Okay. In the second channel, you will need M77 check if phase is synchronized. It's easier to use only one code, G650, and you have all this inside. That's why Machine Builder define to create an automation and to program faster. Okay, let's go back to VMID. So we have 4 patterns and 2 additional patterns used by MCO cycles. Now, in order to see the advantage of the patterns and why we need the patterns, how they help us in programming and in synchronization, I want first to show you an example of synchronization without patterns. So let me open the second part. And here I change the VMID. I delete all the patterns, and I have only one. Axis distribution. All axes are allowed in both channels, okay? X, Z, and C, X, Y, Z, and C, they are normal default in channel 1, but they can be controlled also by channel 2. Also, X2, Z2, C2, they are normal and default controlled by channel 2, but the control can be transferred to channel 1 also. Okay, so we have no rules here. Everything is permitted everywhere. If I'm going to synchronization, let's delete all and synchronize by the CAM tree. No, we don't have any clash because we don't have any rules, any patterns here. Everything is okay. Yes, but not really, because I need to know, using the manual mode here without patterns, I need to know how to assign axis in the code. So manually, I will start to arrange the axis. Hey, X2, you belong to channel 2. Z2, you belong to channel 2, and C2 also, you belong to channel 2. Yes. Here, we have again, X2, you belong to channel 2. Here, in this operation, I see operation 13, start using X2. In order to take control on axis from another channel, I need a label. I need to insert a label, because only on the label, on a weight mark point in the code, then we can transfer the axis control from one channel to another. So here, on this operation, I will need to insert a label, and I take control on X2 from channel 2 in channel 1. Z2 not needed here, C2 not needed here. Go again here, and again I need to take control on Z2, which is still in channel assigned to channel 2. Again, insert a label, take control. C2 I don't need, you go home. Another label. another label, Z2, go to your channel, C, go to your channel, X2, go to your channel. In post-processor, we have new functions. This is the topic of another webinar, post-processor maybe. We have functions to question axis. Where are you? Where are X2? Where you work? In what channel you are assigned in this moment on in this wait mark. Based on the questions, we output G140 manual command with axis assignment. Another label, X2, go to your channel, C2, go to your channel. And this, all this work I've done until now is only to have a CAM3 synchronization. I didn't synchronize anything, it's just CAM3 synchronization, but because we have axes which they can work in both channels, we have to work and we have to assign them correctly to each channel. In the moment that they are assigned correctly, the output in G-code will be correct. If you don't do this, the output is incorrect. The G140 command is wrong. So the end user, the customer, need to do all this. Why? Because we don't have patterns. Let's see what's happened and how this process is working with patterns. Open. Here, this is the VMID with patterns. And we go again to channel synchronization, delete all, and synchronize by CAM3 manager. Now, because I have patterns, synchronization interface here, this will detect the correct pattern for each operation. So here, this interface will detect that I work with X, Y, and Z, and in the second channel I don't have for now any other operation synchronizing in the same time. So it's selecting automatically the default pattern. Now, if I'm going to the second wait mark, it's selecting a different pattern based on axis that the operation is used and axis I define in VMID, in axis distribution. Okay, here again is going back to the default, and here again is changing to the superimposition pattern. So having patterns, this interface will detect automatically and assign the axis. I don't need to come here and take X2, C2, you go home, you go in this channel, and you go in this channel. They are assigned automatically. Okay, I also have a better clash view. Yeah, here, because I take control on X2 in this operation, clash tell me that I need a new label here. I need to take control on X2, which is currently controlled by channel 2. So to take control, I just need to add a label. Automatically is taken, and I have the second pattern, G610, is selected. The patterns are selected automatically based on used axis here, and I don't need to handle and to move and transfer axis from one channel to another. Here again, I need another label. So all what I did is adding a new label, 3 labels, but I didn't take any axis and transfer from one channel to another. It's more simple and more automatic, and it's an automatic process. This is the country synchronization. Let's save and let's simulate. Let's see what's happening. Part will be loaded on main spindle. Okay, part is loaded on main spindle and we start with turning operation on face. I will go and simulate using hand wheel here just to make it slowly and to show everything better. Now we have a long turning operation. And now we have grooving. I think it's clear. Grooving. And finish on this groove. Bring the part out of the guide bushing and bring the wheel. We have a drill using station 23, a drill from the sub-spindle tool post. Back. And milling with live tool, station 6. Now it's a drill. First we drill, then we are going to have a wrap radial profile. And a position to the operation using X, Y, and Z. I'm going slow just to see better. And drill on the same position with tools on this device, which this device can be mounted by the operator cross or axial, perpendicular to Z or parallel to Z. It's fixed by bolts. There are machines with this device on B-axis, a simultaneous B-axis. Here, this device is not controlled by an axis, is fixed by bolts. And this is the drill operation, the same operation, but with a different tool from a different position. And again, wrap profile, radial to the operation also on the position and the drill. Now, the part is pulled out from the guide bushing. Work Z1 is working and C1 and X2 from the sub spindle. Drill on face. Turret is retracting. Spindle, sub spindle retract, and now it came to catch the part before the cutoff. Sub spindle come to the position, catch the part. The grooving tool is bring in the position to cut off. We cut the part and we transfer to sub spindle. Now, with the part on sub spindle, we continue to work on this fixed tool post, turning and internal turning. Also, we can use a milling tool and the part is going to the part catcher released. We release the stock from the sub spindle, and the process is done. Now, as we were done in the previous webinar, let's go and synchronize and to have two parts, adding a new workpiece and have two parts, one part on the main spindle, a new stock on main spindle, and the machined part on the sub spindle. So if I'm going to delete all, synchronize by country manager, going here and say, we start to add the workpiece because on sub spindle after all operations on main spindle. Add a new workpiece, and I will delete this label. I will delete also this label. In order to automate the process and to show you an example of superimposition, I will synchronize the grooving operation with the drilling operation together. Okay, let's see what other problems we have here in synchronization. Yes, I need to add here just a label, weight mark here, and weight mark here. And everything is okay, synchronized correctly. We also have, let's see how much time we reduce machining time. So I will save, export as user defined, and import again the country. So without synchronization, only with one part, which we transfer from main to sub, we have 2 minutes and 30 seconds. With synchronization, we have 1 minute and 30 seconds. We have 43 seconds reduced time. It's almost 30% time saving. Save. Let's go and simulate. One second, machine simulation is loaded. Okay. Now we'll see the stock on the main spindle, a new stock, and the machined part on the sub spindle. They start working in the same time, synchronized. Going again with the mouse wheel here, turning, internal turning here on sub spindle. On main spindle we have external long turning. They work independently, and the milling. Let's go fast. Sub spindle will go to release the stock in the part catcher. Release the stock, retract to home reference. Now we bring the tool, the drill, from station 23. In the same time, I'm having with the grooving tool, with the grooving operation here, Z1 is superimposed on Z2, which means Z2 is following Z1, but is also adding additional moves in order to drill, to pack. Now, finish the drill and continue with milling what we already see. Okay, drilling, milling, position. Machine simulation is very important on this type of machines. Is you don't have very much place here, everything is close and you need to catch the collisions. Again, drilling part going out using the Z1 axis to work on tool from subspindle. And drill and transfer. Catch the part, cut the part, and finish the process. So here we finish the cycle. The part remain on subspindle. After all operations on main, a new part is loaded on main spindle and they start again. The cycle is started again. What about the G code, you will ask? Let's see. We generate the G code and see the synchronization. Window, okay, let's make it small and also open the channel synchronization. So what we have here, we start to work with operation 1 and 2 on main spindle. We have 18 to 22 on subspindle. This is what I need to see here. So we talk about patterns and weight marks. Weight marks on this machine are defined by exclamation mark, L, and the number 10, 20, 13, and so on. So we have a weight mark, L10, and we have a pattern defined. Use the default pattern axis assignment on both channels. Operation number 1 from here on main on channel 1, operation 18 on channel 2. Okay. And they work until this weight mark 30, where we need to change the pattern to G620. Yes, which is G620 is using X, Y, and Z in channel 1, X2, Z2 in channel 2, Z1 superimpose his position on Z2. So right click, I will see this pattern 11S0220. This is the superimposition G620. This is what we see here in the G code. I am loading the tool, activating the spin. Okay, no, not here, sorry, here. Loading the tool, activating the spin, bringing the tool to the first position of the tool pass with offset and activating the superimposition. In the other channel, I just need to load the tool. With superimposition command, I will bring the tool close to the part, 5 millimeters distance from the part, and going to the first position in the tool pass with the offset, having the can cycle PEC G83 to drill. Here we have the grooving tool pass. Now, we talk about, in the previous webinar, we talk about a drive unit. We have the drive unit. Both operations use the same drive unit, use the main spindle, okay? And the drive unit is controlled now by the channel 1. What's happening if we send the control to channel 2? The drive unit now is controlled by channel 2, which means spinning command should be output printed in channel 2. Now, here we have the spinning command S1, which is the main spindle, equal 21900 M3 in channel 1. Generating the J code again. Using window, going down, I see the command was moved, the spinning command was moved, start spindle in channel 2. Channel 2 control the drive unit now and not the channel 1. This is how it's working. Move, transfer from one channel to another. The command will be printed accordingly. And here we go again, we back to default pattern G600 on operation number 5. Let's see and let's check. Yes, we have the default pattern X, Y, Z, and C working on main spindle and channel 1, nothing on the other side. And here we are going to have a different pattern. Operation 13. Let's see. Operation 13 here. We change the pattern to G610, which is I'm using X2, Z1, and C1 axis. Channel interface detect the pattern. The pattern is automatically printed in post. Simple and fast is a better way. We have the cutoff, preparation before the cutoff, and then part is transferred to sub spindle, and we finish the program. Okay, so here I define with the stations 21, 23, the stations on sub spindle, some milling operation. Now I have a different example with turning operations, the same part, but I changed to turning operations. Let's go to example 3. Oh, back there. Let's see the tool table. With tool mounting, it's very simple to add a new tool here. I will also show you how we add a new tool. Yeah, and move. Now here on this tool post, on sub spindle tool post, I change the tools. Turning, I have 2 turning tools, which I will use to create a turning operation on main spindle. In the previous part, we have milling and drilling tools, and now I change to turning. Channel synchronization is the same. We synchronize both together, and we have the grooving and the drilling superimposed. And now instead of milling operation, we have here 2 turning operations. Simulate. Okay, it's loaded. We start to work on both spindles. Now, I also change the milling operations from side to work from cross to work axial. Okay, so the user mount this device on in axial position, the tools parallel to Z. Here in the start of program, I'm having an MCO without G-code output, is only for machine simulation to position my device correctly on parallel to Z, axial position. Okay, it's the MCO cycle that I create without a G-code output, just for simulation. And they start to work. Let's go fast. Forward. Eject the part from subspindle, and now we having the synchronized operations, grooving and drilling superimposed. Go. And we have turning with back post tools. Okay, finish on the main spindle. And internal turning. Okay, let's go here, back. So now we have milling with tools parallel to Z, axial direction. After this, X, Y, and Z, the part is going in and out of guide bushing. Retract, pull out the part and bring the subspindle to catch, cut off, and transfer. Same process. The difference was here that I use this device on 90 degrees and use here turning tools. Well, these are the examples that I have for you today. Let's add a new tool in the tool table. Mounting. Move, okay. If I want to add a new turning tool, add a turning tool, and I select the turret, the position from 1 to 5, and automatically the station, a free position is selected. 1, 2, 3, it already catch, so station 4 is selected. I just need to change the shank to 16 millimeters, also 16 millimeters. And here let's have 20 and 50. Okay. And here I'm going to have move it inside, and the tool, flip the tool. Yeah, now it's in position. Okay. So we flip the tool and we use the shift. It's in position now. So we add a new tool. We can add a new milling tool. Let's see here. We have a free station. I will add milling tool, 6 millimeter. I'm going to 1113 turret, this device, and it will take automatically the free station 11. I have 60 millimeter out of holder, and can change to 40. Okay. That's all. So I define a new milling tool on this station. That's how we define the tools. Create the tool, select the turret, and select the station. What else? What else? I believe I cover everything. Let's go back to, yes. Axis patterns. Again, axis patterns. Here we define and add an axis pattern. You define the distribution, which axis is working, and where is the default. In channels, we select the submachines. Yeah, in each submachine, we define where is working, is channel 1 or channel 2. And also we have a limit of linear axis and rotary axis. Yeah. That's all for today. I believe I was explicit. I know that we have a lot of technical information, machining information, but not all of you are a machinist. But I believe that this is a general knowledge that you all need to know. You need to know the machine. In the moment that you know how the machine, how the controller thinks, and you can use the software easier. Let's see if we have any questions. Questions? No questions. So, without questions, I will thank you.
Okay, Florine, thank you very much. As you said, there was a lot of information given in this webinar. This webinar has been recorded as always, and the parts together with the recorded webinar will be available to everyone later on our website in the reseller area. I'd like to thank again everyone for joining the webinar. I'd like to also thank Florine for giving the webinar. And we'll see you again next time at our next webinar. Take care, and everyone have a great weekend.
Thank you very much. Bye-bye.